Thoman, and we'll leave it to you. Thank you.
Okay, thanks, Gay. Thanks, everyone, for taking time out of your evening. This is what, Gay, the fifth late October kind of Outlook briefing that I've done, and I wish I was in Nome at Northwest Campus right now doing this, but COVID is the world we live in, so I'm at home here in Fairbanks, and as Gay said, I work for the Alaska Center for Climate Assessment and Policy at the University of Alaska Fairbanks, which is located on the traditional and never ceded lands of the Tanana Dene. And so honored to be here. So next slide. Did I do that or did you, Gay? I'll assume you did. Okay. All right, here's where what we're going to do today. We're going to start off here with just reviewing kind of where we've been over the last 6 months with, there we go. Where we've been the last 6 months, starting with kind of the end of the spring, and then take a look at the summer and what happened. And then I want to kind of show you a little bit of this new tool that we have in our climate toolbox. If you're on our Facebook group, you've seen some of this, but I'm really excited about this new tool, and we'll see how this becomes useful for Western Alaska climate monitoring. And then we'll finish up with the outlook for this winter, and spend some time on the sea ice, because that's really what matters most.
Stand by, Rick. I'm gonna switch this to PowerPoint mode, and I apologize to the audience, but
okay.
Stand by one. This will be easier for everyone to see. There we go. Okay. Thank you so much.
All right. So next slide. All right. So here's one of my favorite graphics. This is the February, March, so the late winter, early spring sea ice extent in the Bering Sea, all the way back to 1850. And many of you already know this. Okay, how could we possibly know what the spring ice extent is, that far back? And well, of course, it has nothing like the resolution that we have today. Commercial whaling started in 1850. The captains kept very close track of where they were, and of course, for this season, these are whalers. They are working near the ice edge. So we have a reasonable reconstruction of that. After commercial whaling ended, then we had the revenue cutters. And then starting in the 1950s, we had DOD doing aircraft reconnaissance during the Cold War. And in the 1960s, satellite information became available, and up to the modern age. So 2020, big recovery in the area that had ice during February and March. Big recovery from 2019 and 20. Now remember, this is sea ice extent. It tells us nothing at all about the thickness, the quality, the stability of the ice. This is what is detected looking down. It is for sea ice extent, it's basically a yes or no. But I would point out there that 2020, yes, it's a lot higher than the extent in 2018 and 19. It's still nothing like it used to be, and is really even no better than the typical ice extent in the satellite era. It was actually a smidge below that average. So yeah, it was a lot better than it was, but no, it isn't back to the way it used to be. Next slide. Okay, so ice meltdown. I like to keep track of this. Mostly, I think it's really informative, especially in the rapidity of the decrease in the date. So melt out occurring earlier, and most of the change has been in this century since 2000. So the blue dots indicate each spring when the detected ice extent is becomes less than 19,000 square miles. 19,000 square miles is about the area of the Seward Peninsula. Now this ice can be, the remaining ice can be anywhere. It's often winds up, the last ice is on the Chukotka coast, but it doesn't need to be. This year in particular, there was ice remaining even in Norton Sound into early June, and some more of it north of St. Lawrence Island, whereas in 2019, last year, nearly all the ice that was left in late May there when the area decreased, that was all in the western Gulf of Anadyr. Overall, this was the latest meltout since 2014. And again, meltout has reached that 19,000 square miles remaining criteria, which is better than it's been the last couple of years, of course, but is still below, well below what was typical. That's the solid green line, what was typical prior to about 2000. So since 2000, we have lost almost 4 weeks on the average ice melt date in the Bering Sea. That is really dramatic in that short a time. Next slide. All right, so here is May through September, the average sea surface temperature for that 5 months, and this is the difference from the 30-year average. And what we see here is on the left-hand side is 2019 May to September, and on the right-hand side this year. And obviously there is a big difference. 2019, the 5-month average, those darkest colors kind of off the western North Slope coast in eastern Norton Sound, in Kotzebue Sound, those are temperatures that are 7 degrees Fahrenheit or more above average for that entire 5 months. And you can see the entire Chukchi Sea, almost all of the Bering Sea in 2019 was significantly warmer than normal. That's not the case this year. Well, it kind of is, in that most of the Bering Sea for that 5 months did wind up warmer than normal. Chukchi Sea, mostly above normal. There's a few zeros there, so at normal, that long-term normal, and a small area there off the northeast end of St. Lawrence Island up towards the Strait. That was also very close to normal. But obviously this year, at least at the ocean surface, quite different, and really different from what we saw last year during the warm season. Next slide. Next, there we go. Okay, so I showed one of these last year as well at this late October briefing. So instead of looking at departures from normal in the ocean temperatures or the actuals, so this takes from a higher resolution data set. We take the average over these, in this case, 4 months, and we rank them then. And so the darkest red color there means that the June through September ocean temperature was in the top 5 of the 38 years here that we have to work with. So it's kind of southwest of St. Lawrence Island down into the southern Bering Sea, excessively warm. On this projection, none of the boxes here were the warmest of record. Some of these just southwest of St. Lawrence Island were the 2nd or 3rd warmest sea surface temperatures for this 4 months. Notice there is an area there basically north of St. Lawrence Island through the strait to just north of the Cape there. That was really quite close to normal. Similarly, in the southern part of Norton Sound, also for the 4 months, quite close to normal. And up in the Beaufort Sea, you can see with the more ice in the Beaufort this year, that water temperatures actually were in the lower ranks. So there were more years warmer than not in those blue areas. Next slide.
Rick, I've got a question on this slide, and that is over by Wrangel Island. It's bright red.
Yep. So this area west of Wrangel Island, you can see most of it is that fire engine red, and a lot at this point. This is mostly, not all, but mostly the influence of the extreme heat that they had early in the summer, really through midsummer, farther west. With you might remember that 100-degree report in that made the news in Verkhoyansk and in right around summer solstice, but it was really very warm along the Siberian coast, the East Siberian Sea, the Laptev Sea, the Kara Sea, all extremely warm, very low ice. Ice melted out early, and they have just been they were remarkably warm, really, from spring through midsummer. So some of what we're seeing in that fire engine red is extremely warm water that has worked its way westward along the coast. And so that actually remains an important factor for the lack of ice so far up there.
Thank
So,
you.
Rick,
And you have a question in the chat box from Davis Hovey. Rick, are you getting this year's sea surface temps from satellites or another source?
No, these are all satellite derived. Now, some of these products, like what we're looking at here, the underlying source does incorporate ship observations, buoy observations, that kind of thing. But the basis of most of this is, and all these kind of products that I'm showing are satellite derived.
So Rick, this is Dean Stockwell with a question. This, in the Arctic, this west to east swing in extremes, very warm in the west, very cold in the east, or in the east. Is this common?
North of 70 degrees north, this of course is in part a reflection of where the ice is. So the Beaufort Sea, which had a closer to normal ice year than any other of the sub region, the Arctic seas, that's reflecting that. So if we had a year where there was closer to average ice in the East Siberian Sea and the Beaufort cleared out early, then we would see this pattern. Overall, I would say, yeah, it's not too unusual.
Okay, thanks.
Like 2012 would be an exception on the scale that we're looking at, because it was there was no ice to speak of in the Beaufort or the Chukchi or the East Siberian Sea. All right, still with sea surface temperatures. This is the long view, May to September. So again, the warm season, but using a different data set that actually goes back past 1900. And this is the northern Bering Sea, the average temperature for the 5 months. That's basically north of the Pribilofs on up to the Bering Strait. And you can see pretty clearly what's happening here. All 10 of the 10 warmest years have been since 2003, and every single one of the last 7 years has been in the top 10. So that is really quite spectacular. And if you look back before 2003, you can see, one, there's a lot more year-to-year variability. There's no decadal scale clustering of temperatures above or below that green line, which is just the estimated average for the period. Notice that the 10 coldest years also don't look like the 10 warmest. The blue dots there are the 10 coldest May to September sea surface temperatures in the northern Bering, and they are spread out from the early 1900s on up until 1971. But there's a top 10 coldest in the 1970s, in the 50s, in the 40s, in the 30s, 20s. There's a few more back before 1910. But clearly something is very different. Now, one of the things that I run into getting people that don't really know the region to understand is, if you look at that green line, so that's just the smoothed average. It starts out at the turn of the 20th century, just about 42 degrees. And you run up to, on the left-hand side is now, and it's about 40, 45 and a half degrees. So that's, it's 3 to 4 degree increase. That doesn't sound like much to most folks, but 3 to 4 degrees warming of a 5-month average is in the ocean is really just incredible over that time scale. And really most of the increase is since 1950. And okay, so it's only a 3 to 4 degree increase, but when you're talking about water, which is so dense compared to air, at least, that's a huge amount of heat that didn't used to be in the northern Bering Sea and is now. That is really spectacular. And I would suggest that, at the end of the day, our whole environmental system has changed so much in the region. This is it. The lack of sea ice, of course, is immediately important, but what's driving the change in sea ice, it's in the end and at the long scales, it's the water's getting warmer and warmer. And this is really quite amazing to me. Next slide. Okay, that's enough of the oceans for now. Here's where I want to talk about this new climate tool that we have. It's actually been around about 18 months probably now. But so if you are on the Facebook site, you've seen some products of this. So this is what's called a reanalysis. So if you think of a weather model as a complex computer program that attempts to forecast the weather in the future. It takes in tons and tons of information, got the physics of the atmosphere, the ocean, very complex, but ultimately just addition, subtraction, multiplication, and division to generate a forecast. Well, what this is kind of like the same thing. It's a kind of like a typical weather model. But instead of trying to forecast into the future, we're trying to get the best picture of what's happened right now. And then you start over. And this particular model is run by the European Union. It is the state-of-the-art effort at this. It's what's called reanalysis, or what's happened in the past at this specific time. The area that I've circled there, I hope you can see the different shades of blue color. That gives you an idea of the size of each, what we call grid point or grid box that these values are being derived in. This is about 50 times the resolution able to distinguish features than the original reanalysis, which is still in use, where there's about, I think I wrote it down, about 17 miles, those boxes in the latitude. And that's the previous, or the original one that's still in use is about 135 miles. So this is fine enough scale that we can, as you can see, we can start to get some resolution over an area, say the size of the Seward Peninsula. This is too big to try to pick out, okay, what was the average temperature, or in this case, what was the July 20% of average rainfall at Nome. The box is too big. Gay's house in Dexter is in the same box as just offshore. So you can't use this to find what was the temperature at my house on this date. But at a sub-regional scale, it seems to be doing incredibly well. And that's really exciting to me for Western Alaska, because there are very, very few precipitation measurements in the region. So for instance, on this, you can see that St. Lawrence Island up through the Bering Strait and the very western tip of the Seward Peninsula is in those reds to orange colors, and that indicates significantly below average rainfall. And there are no rain gauges anywhere close to any of those places. But we've been asking folks in those communities about how much, did you have, did it seem like much rain this summer? And we've gotten reports in talking to folks in Wales, Gamble, and Sabunga that, hey, yeah, it was pretty dry here this past summer. And that is really a great confirmation that this new tool is onto something. Similarly, you can see that the parts of the Seward Peninsula actually had a at least normal, if not above normal, rainfall for July here. And so so the question is, I guess we're going to do this by reactions, Gay. So the question is, knowing what you know from your experience, would you say it was a dry summer in Nome?
Okay, so I'm not sure. We were going to try to do a poll, but we weren't clever enough to figure that out once we had started Zoom. So Rick thought maybe if people went to the black bar on the bottom of the screen and you go to reactions, which could be, depending on how your screen is, your bars are set up. If you can't see it, you might want to go to more and see if it's in there. And then you could put like a thumbs up if you thought that if you're from the Nome region, usually a poll is much more, much easier. But let's see. I know we've got Nome on the line here. So if you think it was, what was your question, Rick? Is it drier? Was it a drier summer or?
So do you think, just from your experience, do you think would your impression be it was a drier than typical summer in Nome? And we're going to say summer is June, July, August.
So thumbs up if you thought it was drier than normal. Okay, there's 1, 2 Nome folks. Oh, lots. Okay. We have, oh, they're disappearing. But you had several.
Okay.
Yep.
Okay, second part of that question. Click the thumbs up if you thought it seemed to be a wetter than typical summer in Nome.
Oh, can you see all the
I can't see any of them.
Okay, there is someone from Nome that raised their hand. That's 1.
Okay, just 1. Okay. Do we have a bunch of?
Hey, Kathy.
Do we have more than? Do we have more than 1 person on from any other community in the region?
2 participants raised their hand.
Okay. I know because of the Zoom. I know we're short on outlying community participation, but.
Well, what we can do is wait till the end, and then we can ask that and people can chime in.
Okay.
Okay.
We'll do that. So anyway, so this I'm really excited about this. I think this opens up a lot of potential to help us understand what's going on in the region. We've got KNOM now on board as a cooperative observer, so hopefully we're going to get better snow and precipitation information than we have in the past. I hope that's okay that I say that, Davis. But because of the difficulty with the automated precipitation gauge from the airport during the winter. Next slide. So here's what this looks like. This is using this tool that we were just looking at, but we've zoomed out. So here's the summer temperatures. Couple things stand out to me. One, most of Alaska had a warmer than normal summer. A couple exceptions there. Most of the North Slope was wound up cooler than the 30-year average, and as well as a bit of the eastern interior there as well. In Western Alaska, obviously the warm waters in Kotzebue and Norton Sound stand out like a sore thumb. Each color increment there is 1 degree Fahrenheit. So let's say most of the Seward Peninsula there falls into the, what's that? That's basically the 1 to 2 degrees Fahrenheit above normal for the 3 months. So, and the highest departures there out over the water.
And this is air temperature, Rick?
This is air temperature.
Thank you.
So next slide there. So here, same June through August, the 2020 rainfall. And so the white area is close to the average. So that's actually 85 to 115% of normal. 100 would be exactly the average. So you can see there in this for the Seward Peninsula that we have the first color there. So basically 55 to 85% of normal. So that would be, you know, that's significantly below normal for the summer. And that extends from along the coast, well, really about from Gullivan eastward, and then the western portion of the Seward Peninsula. And then there's that even darker red through the Bering Strait down to Gamble and Savunga, and that's less than half of normal. And it was really great to get confirmation that it was dry in this area, just like our new tool said, and there's no rain gauges in that. So that was really quite interesting for me to see, and really all of this is raising confidence in this. And so that is really information that we can use. And I should say that I'm showing you monthly scale or seasonal scale output. This is actually available every day. It runs about 5 days behind the current calendar. So today's Thursday. I haven't checked today, but there's probably this kind of information up through Sunday at least. So that's really great to see. So quite dry through the Bering Strait down to St. Lawrence Island. But just like we saw in the July graphic, fair amount of area here, pretty close to normal overall.
Rick, Polly raised her hand. Polly, if you have a question, just unmute in the lower left of your.
It was a mistake.
Oh, okay. Okay, no worries. I've been driving like a maniac, so no worries there. All right.
Yeah, okay, so, okay, continue. All right. Okay, so I just thought I'd put this up just to kind of put things in maybe perspective that people are used to thinking about. So these are the daily temperatures from Savunga on top and Gullivan on the bottom. And the scale here this is the daily difference from average since June 1st. And so the red bars are days that were warmer than normal, and the blue bars, downward pointing bars, are days that were cooler than normal. And so a day that's exactly normal gets a 0. And so you can see here that they're similar, both Savunga and Gamble. And I should say these come from the FAA automated stations at the airstrips. They're broadly similar, but they're not in any way identical. In particular, early in the summer, say, well, in June, really, there's more cooler than normal days at Savunga than at Gamble. On the other hand, the most recent time, so this goes up through the 25th, really quite sustained mild weather since the end of September and up through here the 25th. But it is certainly, it's going to be a very warm October for the whole region. Next slide. All right, on to sea ice. So lined up 2018, 19, and 20. These are the Weather Service's sea ice program analyzed sea ice concentration for October 26th of each of those years. So what I get out of this, a few things. First of all, this year looks up north. This year looks a lot like 2018. There is a little more ice in the Beaufort Sea, but not dramatically. You notice there is no sea ice at all along the northern Chukotka coast. And one difference here from 2018 to now. Notice how far the ice is on this analysis from Wrangel Island. In 2018, kind of north of the island, the ice was getting close. It was still far away, but it was getting close. And there is nothing like that this year. That is a reflection of the Siberian and then eventually moving east heat wave and the very warm water that is in there. This year, as of October 26th, there was a tiny bit of ice, just 1 to 3/10 being analyzed in Norton Bay there. And we did see on the webcam at Koyuk that there is some ice there, although at least as of October 26th, I'm not sure that was not all just ice coming out of the Koyuk River. Notice there is no ice being analyzed on the coast in the Gulf of Anadyr, and that's somewhat different than we had the last 2 years. Kotzebue Sound also they did have some ice run out of Kobuk Lake, and I think there might have been a little bit of ice right around the 26th here coming out of the NOAA attack, but I'm not sure there's been much in the way of actual sea ice yet. So that's, we've seen this story before, and it sure looks like we got it again. Next slide. Okay, this is through the 25th. So this is just the Chukchi and Bering Seas combined, the ice extent. And so every year since 1979 is on here. And I've highlighted the last couple of years as well as the long-term average. As of the 25th, we were at the third lowest combined Chukchi Bering ice extent. Really quite remarkable again. And especially since at this point, a lot of this is being determined by what's happening way north, northwest of Utqiagvik. Next slide. All right. So this has been an interesting thing to track this season because ocean temperatures were so high last year. Here's the difference from a few days ago on what the difference is between this year and last year. So no long-term averages here. This is just the difference 1 year to the next. The blue colors, the cool colors are where right now, 2020 is cooler than it was last year. And the warm colors are where it's warmer than it's last year. And these are all in degrees Fahrenheit. A couple things stand out, mostly along and off the North Slope coast, where it's almost uniformly more than 3 degrees cooler than it was last year at this time. On the other hand, most of the region on the Russian side of both the Bering and the Chukchi are warmer than they were last year at this time. Bering Sea near the Alaska coast is pretty complex in this, as river input is a bigger factor. Interesting to see that little area that's cooler, kind of southeast of St. Lawrence Island. In fact, that's a -3 there. And if you were here on Straight Science a couple of weeks ago, Phyllis Stabenow was talking about the cool subsurface water that's evidently in that area as well. So that's kind of interesting to see. But St. Lawrence Island southwestward, it is hot. Gulf of Anadyr is warmer than last year at this time. Not 100% sure of what's going on there in Kotzebue Sound, showing 1 to 2 degrees warmer, given that the summer sea surface temperatures were not as high, but that's what the analysis came up with. Next slide. All right. Our winter outlook. So what do we know? We got sea surface temperatures that are warm overall, and especially on the Russian side of both seas are much warmer than last year at this time. And almost everywhere except for part of the North Slope is above the long-term average. Sea ice, of course, is way below average, although for recent years, it's it's still below the recent year's average, but not as low as last year, but that is a bad comparison for our part of the world, even though the Arctic-wide sea ice extent average for September was the second lowest of record. The Beaufort Sea kept our area from being as low in sea ice as we saw in 2019. And then the big player that's not local or regional is La Niña. You've probably seen this in the press or read about it. So I thought I'd take a little bit of time to explain what La Niña is and how that could affect our weather this coming winter. So the little diagram there on the right is my little tool. I've kind of highlighted Alaska there to give you a perspective. At the bottom is Antarctica. The equator's drawn in there. So what is La Niña? Well, La Niña refers to equatorial Pacific sea surface temperatures that are 0.5 degree or more below normal in the area kind of south and southeast of Hawaii. And so when I say south and southeast, I mean like 1,000 miles south of Hawaii. When we see those kind of conditions across the central and eastern Pacific that are cooler than normal, what that does is it tends to focus those giant tropical thunderstorms way far west, north of the Solomon Islands, kind of the Papua New Guinea area. That's where the big thunderstorms get focused, because the water east of there, by the time you get east of the dateline, the water is actually too cool to support those big tropical thunderstorms. And that's actually how water temperatures, near the equator could possibly affect our weather. It isn't that the waters themselves are going to do anything. It's where those big tropical thunderstorms are sustained, which they in turn influence the jet stream as it comes off of Asia and crosses the Pacific. So what happens in La Niña conditions is that those thunderstorms are focused very far west. And that means as the jet stream comes off of Asia, because of that extra energy being added by those western thunderstorms, it comes off of Asia and gets east of Japan, and it tends to weaken. And what that does is it tends to support high pressure building over the Bering Sea, especially the eastern Bering Sea, which means that storms tend to stay away from the region. What storms do come along tend to run pretty far south, like the Aleutians before moving into the Gulf. And so there's the potential for Western Alaska, and really most of mainland Alaska, to stay on the cool side of those storms. And so the default assumption is La Niña tilts cold for our part of the world. Now, there are several, of course, caveats with that. The most important being the effects of La Niña tend to be most consistent and, in some extent, strongest after the first of the year. So that a cold late winter is more likely than, say, a cold early winter. And the other feature of La Nina, and we'll talk about this a little bit later, is that the way this works, unlike El Nino, which is kind of the opposite of La Nina, there is often very big changes in the weather pattern on the couple week to a month time scale. And so we'll take a look at that. Next slide. All right, so here is Nome average winter temperatures, and by winter here we're looking at core winter, so December, January, February. And right now we have a moderate La Nina. That means the equatorial Pacific waters are between 1 degree and 1.5 degrees below average. That's since 1950, there's only been what is that, 11 of these winters. And here's how the midwinter, December through February temperatures have worked out for Nome. So prior to the late 1970s, there were 4 of these, and all of them were significantly colder than the long-term average. Since the mid or the late 1970s, you can see there's a real, there's much more of a mixed signal. There's a couple of winters there that for the 3-month period were not very far from normal at all. There's a couple that were a bit above normal, and really only the most recent of these moderate or strong La Ninas in 2011-12 wound up significantly colder than the long-term average. And I've also put on there as text some indication of this big giant swing in temperatures that can occur. If you're of a certain age, you remember the super cold January 1989, and the 3 weeks of super cold weather, and including the still standing 54 below in late January. But that was immediately followed by one of the warmest Februaries of record in Nome, and really in many places. That is still the warmest February and the warmest winter month by far of record at Utqiagvik that February. Nome had in very warm temperatures, almost constant storminess. It was either raining or snowing most of the month. And that followed a above normal temperature-wise December. So for the winter as a whole, it was perfectly normal. But the month-to-month weather was very dramatic. Saw a very similar thing in 1999-2000. Very, very cold December, and then I think it's the second warmest February of record. Really dramatic swings in these La Nina winters. Now, why have we seen these big swings in La Nina winters recently? By recently, like the last 35 years. That's an interesting question, but an obvious, possibly not correct, but obvious answer is that ice and sea surface conditions during the winter nowadays are nothing like before the late 70s. That it simply is a different world. It's an apples to oranges comparison here. So what do and this is specifically for Nome, but we see the same pattern all across Alaska, or at least mainland Alaska, where these big swings are much more frequent in La Nina winters than El Nino. And we've demonstrated that there's much more day-to-day or week-to-week variability during these La Nina events than El Nino winters, which tend to often stay the same pattern for a long time and not big swings, more than a few days. Next slide. All right, first I'm going to give you the sea ice forecast from the CPC's Climate Prediction Center's experimental sea ice model. Comes out once a month. This one is getting pretty stale now. It came out in early October from information from late September, but that's the latest we got. Next one should be out probably next week. So I've from on the color bar, and then I've added some text there to indicate what this model, which is actually a collection of 20 different runs of the model. So this is an average of those 20s of when the first day that sea ice concentration will be 15% or more. And so you can see this has ice building in eastern Norton Sound before November 1st. Well, guess what? That ain't gonna work. It has the ice there into Nome area in early November. It's possible there could be 15% by then, but I wouldn't count on that. Down through the Bering Strait, late November, again could happen, but notice along the North Chukotka coast, it's got ice before November 1st, and again, that is not happening. This is also somewhat suspect. This has the ice down to St. George in early March, and yeah, that could happen, but ice hasn't gotten to St. George since the 2011-12 winter, so I'll decline to take any bets on that. All in all, I think this is much too fast, given the water temperatures that we have, given the very warm October that we've had, and hint, those of you in Nome land, there is a potential for a significant southerly wind storm about a week from now, next Thursday-ish timeframe. Even if it doesn't wind up being a coastal flood threat, it seems very likely there's going to be a long southerly fetch of winds. And so, okay, now it's November 4th or 5th, and there is going to be very little sea ice, certainly in the Bering Sea, and nothing of this is going to help ice form in the southern Chukchi Sea. So I would push all of these dates back at least 2 weeks. The color bars are basically first half or second half of the month. So if you push those back at least a half month, it might be at least have a fighting chance. So we will be at the time of the year, here in a couple of weeks where things can change and usually do very quickly, but ain't going to change this fast, in my opinion. Next slide. Okay, so same model. Here's the average sea ice conditions for November and December. And they're in 15% increments, so less than 15%. That's the open water criteria. And again, this is for the whole month now. This is not for a particular day, so the average for the month. Again, I think this is, especially December, I suspect is too fast. Interesting to see in Norton Sound that the concentrations for average in November are still pretty low. That's actually quite different than what this model had last year when I was showing this. Actually had significant ice there in Norton Sound for November. Next slide. Okay, January, February. I'm not sure what to make of these. Well, the first thing that we can see is that this is having a very difficult time developing ice south of the Bering Strait, or solid ice, or what it thinks is solid ice. The only bit greater than 75% there in February is in the western Gulf of Anadyr and maybe like Norton Bay. What all of this indicates to me, this looks like this model at the time that it was produced in late September was trying to produce a lot of south wind. I don't know how else you would get these kinds of ice concentrations for monthly averages. So if that's the case, that could make for a very interesting winter, of course. All that, enough open water that, storms could produce a lot of snow. Next slide. Okay, Climate Prediction Center's official outlooks, starting off with November through January, the early winter season. So you can see Western Alaska has a strong tilt towards warm. That's the left-hand side, the warm colors. Nome, about a 55% chance that early winter would wind up on the whole in the significantly warmer than normal category. Similarly, but not as strong probabilities, tilt towards above normal precipitation for all of Western Alaska. And again, this is almost entirely driven, this forecast, by the lack of ice and the above normal sea surface temperatures. Next slide. Okay, core winter looks very similar. The tilt towards cool expands for southeast and into south central and the eastern interior, but Western Alaska, very similar. If you look close, you'll see that the temperature probabilities on the left-hand side, they're not quite as high as they were for the early winter season, but they're still about, this would say about a 45% chance that temperatures for the 3 months would wind up significantly warmer than average. That still leaves a 55% chance that they would be near to below normal. Precipitation almost identical to early winter, a tilt towards above normal. Again, this is the precipitation being driven by the ice and the ocean temperatures. To be fair to CPC, this is a really tough forecast. You've got the ocean and ice signaling one way, and you got the La Niña signaling another way. So this is a really tough forecast. Next slide. Okay, and so here now we go into late winter, January through March, and you see we've lost the 50% area of significantly above normal that we had on the North Slope. The chances are tilt towards warm, but they're pretty weak. So that would be about a 40% chance of significantly above normal for Nome. That leaves 60% chance of near to below. Precipitation, not much change. So, but as I said here, and as we showed in that Nome graph, I guess what I really want to emphasize is that strong swings in weather patterns. We've had multiple of these La Niña events that have had really big swings. And that I think is really more important than what the 3-month averages would be. This really seems like the kind of situation where, you know, we might get 3 weeks of really cold weather, and then the pattern changes and boom, it's storm after storm after storm after storm. And with water temperatures above normal, if ice extent is not much better than normal, those storms could produce a lot of precipitation. I think, you know, the lessons of the last few years, you know, have reinforced with the ice coming much later than it used to in the Bering Sea. Even if the ice is pretty far south, there's nothing to it. And if we get into a stormy pattern, we'll see the very rapid loss of ice like we've seen the last few years. And you know, if the timing of these patterns shifts, the timing of the pattern shifts are such that they occur when the ice is very minimally developed, you know, there's a potential for big problems if we have to basically start over growing the ice after one of these storms come through. You know, it's the kind of situation that could lead to like what we saw in 2018 when we've got open water and coastal flooding at Diomede on Valentine's Day. And I'm not saying that's gonna happen, but this is the kind of situation the atmosphere and the La Niña would support these big swings. And so I think it behooves us, you know, you hear in the media, oh, La Niña's coming, it's gonna be cold. And I would guess there is gonna be some cold weather, but I'm also think it's quite likely we're gonna see these rapid and sustained shifts in the pattern where, you know, just because it's been cold doesn't mean it's going to stay cold, or, okay, one storm will come along, then it'll get cold. That might happen, but I would look for and plan for these big shifts, and depending on the timing of those, then we could see problems that we perhaps weren't looking for if you just listened to the media reports. Next slide. So here's where I summarize all that. One thing I wanted to have here, if we've got time, you know, old folks like me, you know, we like to compare a lot of this stuff to the, you know, back in the day type stuff. You know, I'm really wondering if it isn't time now to, when especially talking about ice, that we kind of give up on, except for very specific purposes, the, you know, the 30-year average or that kind of thing. And really we start to focus on comparing ice to what's happened recently. Things have changed so much. I wonder, and I'd like your opinion on how useful that is when we're providing these forecasts. I think that's what I've got for the summary. Next slide. And that's what I got for you. So thanks very much. A beautiful view there from Diomede last December. So Koyanak.
All right, thanks, Rick. I'm gonna stop sharing, but we can, if people do want to go back to the slides, we have that option. This way, there, Rick will be bigger. Okay. All right, well, thank you so much, Rick. I am sure there are questions. I know I have some, but let other people go first. Any thoughts or questions or comments regarding the use of what you just said, Rick, the 15-year compare or the 30-year comparison? Maybe that needs to be shifted or not. That was a question you had. You did have a question in the chat box, although you can't see it. It came to me and it says, I missed what the tool is, the higher resolution tool that like you had for the July rainfall, what the tool is called, or how does it work other than that it has greater resolution? There's someone who's interested in that.
Yeah, so this is can you hear me?
Yeah, how does it do its magic?
Right. So it's called the ERA 5, number 5 reanalysis. It's run by the European Union, and it's basically a weather model that's not trying to forecast the day-long future, but rather it's trying to recreate what happened, what the condition of the atmosphere was like at a specific time. In practice, it's actually like it is a weather model, but it's just run out. It's only run 1 hour at a time, and then you start over, and you forecast the next hour, and then you start over. And so this very fine resolution is that's new that's the best that we have in the world for real time, like within a few days. You can run research models at finer scales, but those are going to be for very specific areas. The European Union Met Service is known for its ability to incorporate every scrap of data, satellite imagery and the information that comes off of that, radar information, regular weather observations, and process them in a very detailed way. And so, and of course, all this requires an immense amount of computing power to do this. When you're forecasting for a state 1 hour, and then you start it over. And this is for the whole world. At that scale, that is really, it's really quite amazing. And I dwelled on the precipitation issue, not just because we have so little of it in especially Western Alaska, but that is so hard to get. You know, just think about your own experience. There's such short distance variability in how much precipitation falls. And again, we're not trying to, you know, this isn't going to get you the rain at your house in July, but it sure looks like it's doing very well on the regional scale. And we've even seen that here in the interior. you would expect at that scale, even though it's really good, to not do very well with thunderstorm rain. And it looks like it's definitely in the ballpark. Might not be in the dugout yet, but it's in the ballpark. Does that help at all?
Yes, I think so. And you have another question. It's from Carol. I read there was a little ice. I read there was a little ice age from about 1450 to 1900. Is there any way to know about climate in this area prior to that time? This being the Bering Strait region. Ancestors of people in this region would have been dealing with somewhat warmer conditions then. Mentioning this in contrast to focusing on the past 15 years.
So yes, the little ice age was about the time frame you indicated. It was most pronounced in Europe, although there are reflections of it in North America. It was definitely not a global type event. It was mostly Northern Hemisphere and mostly, but not exclusively focused in Europe. I was going to say, I don't think we have any way to reconstruct ice in that time for Western Alaska, except for this very recently published paper that looked at different isotope ratios in peat on St. Matthew Island, and concluded that the ice extent that we had in 2018 had not been that low, at least for that area, in the 5,500 years that peat bog has been developing. And they do have the reconstruction of that does show that there's been less Bering Sea ice in the springtime. Not every year, of course, but the trend has been for less and less for at least 4,000 years. So
right.
I'll just leave it at that.
Sounds like you nailed it. That's great. Any other questions for Rick? It does sound like to me we need to fasten our seatbelts. I thought we were just kidding around, but when we did the poster, but I think we should buckle in. From what it sounds like, we could go heavy on storms and heavy on open water if we get those storms.
So it looks like there's a question in the chat from Sean.
Thank you, Rick. In the 2019-2020 temperature comparison, slide 11 to 13, it looked like it was warmer in the coastal zone near the Colville or Sag River, I think. Do you have a sense for why it's so much warmer this year? Do you want me to go back?
Please.
All right, everybody stand by. Let's see. Which slide? Do you know which one he's talking about?
Probably near the top, I think. Oh, was it that one you were, the rainbow color one you were referring to?
Yes. I think it's 2 slides forward.
This one?
Yes, that one.
Yeah, I'm not, the obvious answer there would be, yeah, that's related to, that must be related to Colville River discharge there. It is interesting to see that, and I guess that would just be, okay, maybe that's the explanation, but I don't have any reason to think that other than where it's placed. Like, why would it be warmer this year there with that discharge than last year?
And just to say, where you're talking about is east of Utqiagvik, that yellow dot on the Beaufort Seaside, northern side of the map of Alaska.
Correct. But yeah, that would just be speculation on my part, and it may either be actually warmer. You know, you do have to take these, even though this is pretty high resolution, you do have to take the right on the coast values with a grain of salt. This is the same model that we saw big discrepancies between different analyses in Eastern Norton Sound. early in the summer. And that was probably related to the patchy ice that remained. That's not an issue right now, as at least there's not a lot of open water left on the Beaufort side, east of Point Barrow. And this is I think for the week ending like the 24th or 5th or something. So I'm not 100% what that is trying to show.
Okay, thank you.
So Rick, I have a question. It looks like for the Russian Chukotka Peninsula and Siberia, they are sort of having what we experienced in 2018, where it seems like, at least from my limited knowledge, right, their ice is taken off on the northern sea route, has taken off offshore, and it's still open in the East Siberian Sea, clear back to Europe, I guess, right? And we're seeing, like right here, you can see these hot water is, I mean, in 2018, this region experienced, with that sort of condition, sort of a massive ecological transition. Do you have any knowledge, or you hear of anything where Russia's going to have, I mean, it seems like they would be in a position to have that sort of thing happen to them, if that's possible. With the temperatures, they're shallow up there in the north, shallow water, and we're getting these warm temperatures. I mean, do you have any indication that's, I don't know, that's, seems like that's a big player. It's going to influence our ice, but I also wonder how that's ecologically, though that's not your forte, but how that potentially may affect not only their waters, but eventually what's going to happen as that comes into our waters in the Chukchi Sea and tries to kind of mix and come down. And I see there would be lots of problems potentially for making that ice.
Yeah, so there's the whole, the water and the warm water transport issue. The ice in the Bering Sea is highly variable. So I mean, in the end, it's going to have to all affect. One of the things that I wonder about is maybe the middle term, maybe the few decade term for the Alaska, the Bering and Chukchi ecosystem. Are we going to wind up having Atlantic side fish work their way eastward across the North Siberia area as there's open water longer and longer and thinner ice? Most of the Siberian coast is farther north than Alaska, than the Alaska North Slope coast. So that might slow them down, but I wonder if over the few decade term, if that's going to become an increasing issue.
Well, for people who live in the Bering Strait region, and I know I saw your name, Lyle, this is sort of a little news flash, I guess, is that there have been reports recently, as of this week, of at least 24 stellar sea lions on Fairway. So there's stellar sea lions utilizing a very sea lions, what we sort of normally know. They're utilizing in number an area that's kind of north. You can always find sea lions this time of year at St. Lawrence Island, but it looks like in number, and this was on a tough weather day, that the sea lions were in number on on Fairway Rock, which is a small granite rock island that sticks up to about 500 feet, about 10 miles southeast of Diomede. So it's interesting to me because food is what brings those sea lions up here at this time of year, and it just seems to me that the water might be warm and the fish that stellar sea lions like to eat must be near. Perhaps we're kind of stretching on it because we haven't had the research vessels here this year in any kind of great number. So I just thought that one was sticking out for news for this region regarding sort of water temperatures and ecological events. Any other comments from the Bering Strait region or other places? I know we see a lot of names from outside the region, not outside, but outside the region. If not, I want to thank Rick. Oh, there's some chat.
I actually had a question, Gay, that I stuck in the chat about.
Okay, yeah, I just thought it was flashing. Go
Oh,
ahead,
okay.
Molly.
It's one of the first slides that shows sea ice extent. Can you pull that back up?
So it's in the beginning?
Yeah.
Okay. Say when.
Okay, there's quite a delay on mine. I'm guessing it's the very first graphic. And
Is it
I'll
the-
also compliment
hang
Rick on
on.
his great graphics.
Thank you.
Just a few more.
Can you see
Okay,
the
I think-
1850?
Yeah, so, okay, it's that one.
Okay.
And so this actually leads into, Rick is wondering about whether we should, have a new set of averages. And I guess I thought that's what I heard the Weather Service was going to do was that they use 30-year averages. And so the 30-year period changes every 10 years. I'm someone who wants the whole data set because especially this graph shows it, like you would miss all that really old stuff. And I think it's important for all of us to remember what it used to be like. My actual question about the graph is, if you look in the period around this, like the 60s and 70s, it just seems like there's these really big variations after a long period of pretty steady temperatures of ice extent. And I'm just wondering, was something going on there? And then we have sort of modern times with much less ice extent. It just seems like a real clear change. Or am I just reading more into it than I should?
No, that's a great question. I think before the Department of Defense reconnaissance flights started in the early 50s, what we're looking at before that is, I think, a much more smooth record that, some of these years back in the 1800s, there are very few observations. Other years, there's quite a bit. There was a lot of activity with commercial whaling, and that was happening in the Bering Sea. So some of that is there's comparatively a lot of observations, but of course it's nothing like what we have even after the DoD started their once or twice a month reconnaissance. So I think the pre-1952 record is really a smoothed record. If we had, if we could launch our satellite in 1850, we would see more ups and downs with this than we start to see after the aircraft reconnaissance start. And like some of this, there's areas in the Bering Sea where there were more whalers, other areas where there are less, so we're probably not capturing that. But even with those caveats, there's nothing to indicate that, for instance, that any year since 1850 was even vaguely like the 2018 and 19, and that Pete study from St. Matthew Island would suggest that too. So I think that pre-1952 is the smoothness of it is probably something of a data artifact.
Thank you.
Good, Rick, this is Dean Stockwell. Doesn't that argue, though, you need then both views of the system, one that keeps the touchstone from the past, but yet the new modern one? We're in a state of flux now. And if you look in the last, 10 years, the normality kind of disappears. So we're still changing. We're going to continue to change for probably a time frame that we're not quite sure of yet. And so we need both views in all our models. So I would argue to keep both.
Yeah, thanks, Dean. Yeah, I suspect you're right, and it's certainly going to depend on the purpose. And just to address your comment there, Polly, that, yeah, so the Weather Service and the world, by international agreement, update this kind of the standard climate, like temperatures, precipitation, once every decade. And that will be happening for the current decade sometime next year. So for temperatures, precipitation will go to 1991 to 2020 as the standard normals period. For sea ice, though, there is no standard at all. I was on an international teleconference this morning where they were using 8 or 9 years as the normal period. Other ones were showing ice with a 22 or 30-year period. And this is all in one teleconference. So there's no standardization with ice. But I think Dean's right that we're gonna have to be flexible in what we do with sea ice because the trends are so very strong. And that's gonna make a requirement for folks like myself that are trying to deliver this information to folks in a way that's useful to them. We are going to have to pay very close attention to what the use of this information is and make sure that we make that clear, whether we're talking the ice we expect to be like this compared to what reference period. And that's but I think it's going to be that way for a long time. What's the purpose? What do you want to get out of this information?
Well, thanks, Rick. There's some other comments in the chat about the stellar sea lions. The observation of stellars on Fairway Rock marches or matches a little later each year in recent years. And know that and this is for Lyle, Phyllis Stabino from NOAA's PMEL laboratory in Seattle. She's a physical oceanographer, and she had Straight Science a few weeks ago. She showed the water temperature. She was on the hunt for the cold, briny salt water that would, resides on the bottom after the ice formation. And she was showing the results of the moorings that NOAA has, the you could help me out here, Rick, probably M2, M4, along the sort of on the shelf break, eastern Bering Sea going in a northwest direction. Those sort of showed colder bottom water to some sort of model that was indicating that would be the case. However, she did have real time from the ship water temperatures, bottom water temperatures that were from south of Diomede, kind of between Diomede and St. Lawrence Island. And those registered quite warm, those bottom waters, warmer than those moorings would indicate. So it's interesting that the sea lions are there in number. You can get, a sea lion here and there, but they're there in number, and it was bad weather. So they would have probably peeled off the rocks a little bit more, but they were there and they're staying there, and probably what they're eating. I'd love to have a sea lion stomach to see what that would be inside, but I just wanted to point that out. So yeah, those sea lions might be really good indicators of the temperature of the water all the way to the bottom there. And then Dwayne Stevenson wrote, wow, I hadn't thought about species coming that way. When you were talking, Rick, about species coming over on the northern sea route, we've been thinking about species coming across from the Canadian Arctic, but not across the Russian Arctic. And that has a lot of implications. Dwayne is very knowledgeable of fish, and certainly people in this region are very knowledgeable of marine mammals, and that makes me think, we do sometimes get marine mammals that come over from the Canadian Arctic, like hooded seals or narwhal, that sort of thing. So it's, yeah, you made me think there too. The animals will follow the food, and what we might see, or what the European Arctic might see from this side as well, if it's a true exchange. So thanks for bringing that up, Rick. Any other comments or questions? There is little claps, I think, in your reaction you can do, or you can just show your love for Rick right there on the chat box. But other than that, I guess, thank you so much all for coming, and thank you, Rick, for always taking the time. I would like to point out that Rick has been spending last night and today talking over the telephone because of our digital divide with our more Western communities to provide them this information as well. And we really appreciate his time to talk with people on the ground that are relying on this ice and weather forecasting that just don't have the opportunity due to the lack of broadband internet to participate. Thus, we have taped it as well. So I'm going to stop.